it's asking you to find your v in the horizontal direction at the beginning, your VXO. So in this problem, I do not have time. I need to find time of flight first. So I know my kinematic equations. You can look yours up. Okay, I'm going to use equation number 1 because I have all of the information that is necessary for me to solve using this equation. Okay, fill in your given information. Remember, 0 times anything is still 0. Okay, now we're going to do some algebra. First, I'm going to subtract the 250 from both sides, so I get negative 250. And then I'm going to apply 1/2 times negative 10, which is negative 5. And you don't have to worry about your units carrying through. It all works out in the end, I promise. Okay, now I'm going to divide both sides by negative 5 to get t squared by itself. And then take the square root of both sides. So the time of flight is 7.07 seconds. If you wanted to round at 7.1, that's fine also. Okay, it just depends on how much of a stickler the person that is grading your papers is. Okay. That does not answer our question. Keep that in mind. We are not done. Okay, the final step is finding the VXO. There's only one equation that I can use in the horizontal direction because there is no acceleration. So that's this equation. And that's your kinematic equation number 2. But since there's no acceleration, the 1/2 at squared goes away. Okay. Plug in your numbers. And then solve for your velocity. And there's your final answer. What if I ask another question about the same problem? So keep all of our givens. But what if I want to know what is the speed when the object hits the ground? So let's take a look at what is happening here, okay? Just to give you a visual. The object, the ball, is going like this. We know that we started 250 meters above the ground and it landed 300 meters away. We just solved for our horizontal initial velocity, right? We know that the time it takes is 7.07 seconds. I want to know what is the velocity when it hits the ground. I like to call it my resultant velocity. So what that looks like in vector terms is this right here. Okay? Now remember, we've learned all about how vectors add. Remember, when you're finding the hypotenuse, we're using right triangle trigonometry. Please keep in mind you cannot use your displacements. Displacement and velocity are completely different variables. Please do not mix them together. So what you need that we don't have yet is your vertical components of this triangle, the velocity when it gets to this point in the vertical direction. So in order to solve that, we're going to use equation number 3 from our kinematic equations.